Okay, Neeraj Pandya.
Yes, I have joined. Yes, sir.
Yeah, do you have any issues to discuss?
No, at the moment.
Okay. Kaushik, I think you are also coming after many weeks.
Yes. No question. Just join to learn.
Yeah, after a long time. Okay. Okay, I think here Mr. Anish, he is means they are doing many tanks projects on that one. Yeah, if anybody want to discuss anything, I think he will help because he's more about tanks and that one. But in our group, I think very few are there who are doing the tank projects and that one. So
Yeah.
yeah.
Then I have a question actually. This floating roof tanks, how it is different from other types of tanks in terms of design?
Yeah, Anish.
Yeah, this one floating roof tank actually normally we are doing another in like same like a vessels, no? You know, this pit vessels, you know, that inside pit you have calculator, one of the biopsy calculator, right?
Correct, biopsy.
Yeah, same like biopsy only we are going with the floating roof that tank inside floating around side. Then some critical that one, yeah, some drainages calculation, that's when we are doing that one.
Apart from that, nothing. I mean, nothing complicated.
Yeah. Not complicated like that.
Okay, I want to add something in here because we also done.
Okay.
In cone, Ramakrishna, did you done cone roof tanks?
Yeah, cone roof tank I have done,
Okay.
but not floating.
Yeah, in cone roof, normally that end is connected to that the curve angle and that one, no? So in floating, it's directly floated on that liquid, and that liquid when it floats, so we provide normally it's two, three different types. One single deck floating, double deck floating, and pontoon floating. These are 3-4 different types are there. So in single deck floating, there is only one plate which is laying on that liquid, and at end there are pontoons. Pontoons means there are empty spaces are available, means as in boat how we will keep some gaps, no, that. So there is some pontoons are available which makes that plate to be floated on that liquid, and that to be calculation as Anish told, that it's buoyancy calculation. We need to do buoyancy calculation, how much that pontoons or that size to be maintained so that it that plate to be floated on that liquid. And to take care this rain water and that one, we normally provide one drain connection at the this floating roof. So that drain connection, it's directly routed to the bottom of that tank, so that liquid whatever collects on the rain and that one, it will directly downs to the tank outlet. So that is another condition.
Will it mix with the storage liquid?
No. That's why the drain is connected at in the center. They will make one drain.
It's like a drain is connected to another separate compartment.
Compartment not. It's it is tilting type. It's not a straight pipe. It is a tilting type. It means whenever that float comes down or up, it tilts. Means it's bending type. It's a zigzag type. It is. So it will be comes down and it becomes smaller in that one, the zigzag, and when it's flexible type, you can say. This
is it like something floating suction or something like that?
Floating suction, it's not that the float which when it comes down or up, no? When liquid comes and down, up and down, on that time this drain nozzle also it's bends accordingly the length of that one, the float where it stands. Okay, this is second one, and third one is that
flexible pipe. I mean,
flexible pipe, or there are some flexible connections to be connected to that one, so that it can flexibly the length means height will be varies. So this is one, and third one is that to land on that floating roof, also we provide this flexible type ladders, so that whenever we go on the top. So when this the float comes up, down, and that one, on that time you can that ladders also to be at that level only. When it floats comes, means your liquid is down, so it will become that ladders also will be down on that place. And fourth one,
So,
yeah.
yeah.
And
Yeah.
fourth one, when this float when comes to down, when you are draining complete the liquid out, no, there are some legs are provided to stand that floating that deck on the bottom, so that it not hit the bottom plate. So
Oh,
there also they provided that legs also provided, and there is one more
it's
also.
like
Yeah.
it's like a stopper
Yeah, stopper. It that top deck should not hit the bottom plate.
bottom. Yes.
Bottom plate. So they'll provide that legs.
So that is to maintain some minimum liquid level.
Minimum
Something.
liquid level or complete to drain that one. This whatever the inlet, this drain and
Yeah.
that pipe, it should not be get crunched or something. So they
Okay.
provide that one. And also there are some requirements like the secondary and primary. These are what you call the vents are provided. Ashwin, Anish, do you remember that primary or secondary, the end what we provide that one? The normally when this float means little bit it tilts, no.
Yeah.
We provide some sealing on that. Means it's even if you tilt that one, primary and secondary seals will be at the end of this floats. It will be available, so that it floats, and that one it will be maintains that one. Means it's not gives any gap on that one. And there are some vents will be connected where there is some gaps in that one. No? That's we normally called primary vent and secondary vent. Primary vent will be normally on the roof side, and this ceiling side there are some other vents are available, additional vents where you can this additional where the gaps are there. No, from there the gases should pass. So these are few things in floating roofs we have to take care. Right, Anish?
For between that roof moves up and down. So what kind of arrangement with the shell, because it has to move freely depending on the liquid level, no? So how
Arrangement means it is
what kind of that ceiling will be there on the side of the roof?
yeah, that's a primary.
Yeah, ceiling will be there. That's why they told, no? The ceiling will be there. Then one vent also there in shell side also. If anything happen in a vacuum side, no? Then one vent, shell side also one vent. Then ceiling will be there actually.
Yeah, primary and secondary ceiling. Normally,
Primary and
secondary seal. These are two connected. Means primary, it's a small one, and means it's made. There are two seals they provide when your double deck floating roof is there. So these at end of this floating the plate whatever there, you know, it will be at the end corner it is. So whenever your floats will be tilts or something, or maybe because you should not be keep any gap between this shell and this roof, so that the gases should not pass from there. So they'll provide this sealing and that one.
Yeah.
So even it's a little bit when your liquid is filling or when your liquid is draining, on that time the chances of that roof will be tilting. So to avoid these all, normally this ceiling are provided. These are very big size, maybe sometimes it is 1 meter length of that ceiling. 1 meter.
Okay.
Like that.
So then in the shell design, we need to consider the frictional effect.
Yeah, shell design, no, in normally we consider in this the vent means the inflow and outflow calculation are there. There are, as per API 2000, there are some calculations for inflow and outflow of these gases or liquid. When you are downing the float, there is a outflow of the liquid but inflow of that gases. So on that how much it should be, and when you are filling, the gases are going out and liquid is filling. So how much outflow. So in that, on that time we need to calculate how much the means speed of this float to be moved, or the gases to be considered, how much it the means vent size to be considered. These are as per API 2000 normally we will calculate.
Normally, okay. So, but I'm talking about the mechanical design of the shell, means to decide the thickness. Apart from
mechanical design normally it will be done as per whatever we do as cone roof will do. No, shell design will do same as that one. Only
Same
the
as that one, but additionally, I think frictional forces will come, no?
yeah,
Because
frictional
it is,
force is comes only when it's this when
moving.
roof is moves up and down. And
Yeah.
up and down when moves, and on that time this API 2000 and there are some other codes also, they specify how much the speed to be, means you should not fill the liquid as fast as, so they given some 6 meter per second, right, Anish?
Yeah, correct,
Yeah,
correct,
6
correct.
meter per minute, some they given that value, so it should move
Yeah.
only that speed. So if you move on that speed only, there is friction and that will be not available. So
Yeah.
accordingly it will be designed. So these all calculation will be done when we calculate the vent in and when vent out, outflow of that gases. On that time we'll do that, but not in the shell calculation or maybe on the roof calculation. In roof calculation, floating roof calculation, on that time we include this EPA 2000 calculation also, this gas inlet and gas outflow.
Okay.
And apart from that, the buoyancy calculation, there are some, I think, appendix H, right, Anish? So it's,
Something, yeah.
yeah, it's given in that one, how to buoyancy calculation is done in that one. So accordingly, we
For
have to.
the roof, how the structure is calculated?
So any
Structural
tank,
STAD, based on the STAD only, based on the, yeah.
Yeah.
Okay.
Actually, structural we will calculate based on the some platform on the roof. Then external, if you have the external loads, some like wind load, like no, then based on the STAD only we are doing the STAD calculations.
Okay, for the roof truss also you're doing stat calculation.
STAD calculation, yeah, STAD calculation.
Normally we'll go for STAD only because STAD it's easy. Means the structure person, for him it's a daily work. For us mechanical static, it's for us it's a difficult. So we'll give for the STAD only. STAD it's just as a software. So he'll give some inputs and it will give good results, right, Anish?
Yeah, correct.
Okay. So you mean structure means
for
Kaushik, what
the
structure
drawing,
you are asking?
And for the structural drawing, what you follow? How you follow that? It's normal AutoCAD.
No.
Not,
Tekla also. We are following Tekla. Tekla also following. Actually, roof structure it will come on 2 types actually, internal type and external type.
Okay.
Some structural on the roof, external also it will supported on the compression ring like that. Then another one there internal support rafters. Then stress supported based on the diameters it will vary actually.
So you mean to say you use Tekla, you use STAD, and then for the tank calculation you use I think Excel, right, or any other software?
Tank calculation using for the Excel, in-house Excels. Then structural calculation we go with the STAD modeling. Once STAD completed, they provide the inputs. If you small tanks, we can go with the AutoCADs, no problem. Then bigger tanks, then we will go with the Tekla. It is for good tanks actually. Detailing.
Okay. And what Ravi was telling, the buoyancy calculation, those are all Excel. Nothing.
Excel we can do it. Excel we can do it. Now, right now, some in market some software also there actually in tank, E-tank.
AME tank also there, I think Ramakrishna.
AME tank, E-tank, yeah.
The Ramakrishna,
But
you're using,
those software is not fully capable doing everything, right? It's only doing the
capable. I think capable. Most of people right now using for the Excel only. Actually, it's not developed actually in the software side.
There are many errors we used to get, so we are unable to sort it out with them because this is just they are entering the Excel things into the softwares. So we are difficult, and they are solving. Their response also very slow compared to our other PVLite and that's responses.
Correct.
AMA tank was also not good enough, I think.
Basic calculation I think you can do like cone roof and that one, but this floating roof or any other roof, if you take, it will means if you stuck in some error, then it will be difficult. So how to solve that? And their report also contains many errors. So whenever we'll compare with our Excel this sheets and that one. So we'll find that whatever the results what they're giving, it's not satisfactory what we are getting from our Excel. So we'll continue with our Excel only normally.
Yeah, that's the reason actually what will happen. AP 650 is very silent about this. Not given the proper judgment. Based on the most of things are going with the good engineering practice judgments.
Yeah, yeah. Okay, Kaushik, actually what structure you are looking? Structure means what actually you are looking?
No, actually, I just wanted to. There was discussion long back, like how to do the structural for means how to design that structure. So that time it was discussed like there is any Excel for that or not. So that's why I asked normally how you do the structure, because I think the diameter is very high, right? 10 meter or something like that, more than that. So how we do the calculation for the structure?
Yeah,
So I
actually,
think, yeah, start is a good option. I mean to say.
yeah.
If it
Actually,
is
structure means there are.
if it,
Yeah, yeah.
if
Ram.
yeah, what I'm saying, if it is a simple configuration, like with only one central column and the wrappers are connected, so those things we can do manual. Okay, but for other configurations we cannot do manually. So that's why they go for stack.
Yeah, but Kaushik, structure means there are two things. Ramakrishna, I want to add. Here, structure means we provide some structure for support of this roof.
The
That is
roof,
called as
yes.
rafter supports, and those are considered as a structure. And there are some platforms on the roof. That
Oh, okay,
also,
okay.
yeah, that also
Okay.
we consider as a structure. So, which structure you are talking about, Kaushik?
No, I am now, whatever I am discussing, I mean, that time was discussion was like the roof supporting structure, like the truss.
Okay.
That is a circular truss, right? The circle, and there
Yeah.
are so many trusses are there.
Yeah, that's
So how
called
to
as
do that
a
calculation?
rafters. We normally called it as rafters. So,
Okay, okay, okay.
so,
So those rafters I am talking now means
okay.
the
So,
calculation, how to do that. So anyway, it means I got the answer. The start is I think the best option, right?
yeah,
Or
start.
any other option is there on that. I mean, is any
Stat
other
Pro
way
is
you
there,
can-
and yes,
See, suppose your configuration is very simple. You will provide a central ring and you will connect the rafters, means without any stresses. Then what you can do, you can consider like a simply supported beam and you can do the analysis. So there it will be, you will have a bending force and axial force you can consider, and you can do the simple manual calculation. That some softwares they will do it. That even that intergraph tank also will do it. Very simple calculation. But if it is a complex, like where they will add the additional parts and all those things, we cannot do manually. So then we should go for this one. Yeah.
Stat Pro. Yeah, normally if it is single rafter, means single length rafter, so we can go for the manual what Ramakrishna told.
Yeah.
But if there are primary rafter, secondary rafter, like
Yeah.
that it comes now, then it's we have to go for this Start Pro software. It's a structure software.
Manually, I think almost impossible unless you have very experienced.
Yeah. There are many things because which load where connecting, where transferring, it's difficult.
Yeah.
When you come with
Shop fabrication up to 6 meter we can do it manual calculation. It's okay, not much. Yeah.
Yeah.
No, that normally in that you what do you call the rafters? There is a end points, right? Circular. So that load where it transfers means that load where we transfer that load again.
that sits on
Load transfer to the shell.
that sits
Okay,
on the
that
curve
load
angle
we
at the end.
consider to the shell.
Yeah, shell.
Shell,
Uh,
top shell.
Top shell course. Actually, tank is when compared to different essential part. Actually, it will transfer to the shell to shell. It will come on the last thing, bottom plate. This thing.
Okay,
This
so that means
Kaushik,
whatever load we get, that load we take in the Excel, right? In the tank calculation,
Yeah.
and then we transfer those load. And as per that, I think there is no effect on the thickness. What will affect actually? What will be the effect for that load, the vertical load which will come? Maybe it will not be vertical. There will be horizontal also. So
Yeah, that
normally
load also there. That's purpose we are using for the top shell course, compression shell course. That will coming on the around more than thickness. It is around maybe if you have the 20 meter diameter tank, you record for the cell thickness for top shell course only record for the 8 mm cell thickness. Okay. But we consider for the 18 mm, 28 mm cell course for the particular compression ring. That one also, particular one calculation also there, compression ring calculation.
Okay.
Based on the roof weight, roof weight and roof structure weights, according to the roof structure weights.
Okay, so first we do the stat calculation, and then that load we will take, and that load will again do the calculation for the shells, right? That is the mechanism.
Yeah, back calculation.
Yeah, I want to add something. Kaushik, this you are telling this rafter is coming where this load is transferred, where it sits, at the end of that top shell. So that place it's called as curve angle. There is one angle is there, so it sits on that one, and then the load where it's sitting, that part particularly will consider 200 or whatever that as Anish told that's normally we consider a thicker plate on that part only, that particular part. That is compression ring normally we'll use to call, and that is more thicker than that whatever the other shell thicknesses. So that to take this load and that one, it will be calculate this compression ring thickness, then other thicknesses. So these all are calculated in roof calculation and that the shell thickness calculation after the getting the complete loads or whatever the weights we are getting on that one.
Okay. So if I say the compression ring means throughout that, right?
Throughout means full top circle. Shell, top portion it will be.
Yeah, top portion, full circle.
Yeah, full circle.
Full circle. Yeah, it will come on 400, 500, 600 like that width only.
Yeah, it's okay. It will be both side on top shell also and top this roof plate also. There is a means at the end of the roof where it's sitting.
Yeah, correct.
Yeah, that place also it will be thicker. So both will be considered thicker side. That's compression.
Okay, so I mean to say normally the thickness below shell, the top bottommost is the highest. Then it is reducing, and suddenly in the top it will again increase.
Yeah, suddenly increase means as per calculation we will provide whatever the thickness we'll get. We'll provide that compression ring thickness.
Okay.
But I don't think generally there will be an increase.
Compression ring, if the size of the tank is bigger, then it will increase. If you're 25, 40 in diameter tank.
Yeah, correct. Yeah, based on the size of the tank only it will increase actually.
Yeah.
But the top shell core thickness will not change, right? It will be.
Yeah, bottom means whatever calculation as per 1 foot or that one, whatever we've done, it will not increase that one. But when we calculate the compression ring calculation, on that time you have to consider that one. Whatever size you considered, that length of that compression ring, you have to calculate separate calculation for that one. Okay, Ramakrishna. Kaushik, Ramakrishna, how much big size tank you done?
16 meter.
Yeah, 16. Still it's smaller one. 40, 30 or 60 meter diameter it will be bigger. Means you will get.
Yeah, it will record actually. Yeah. More than 25 meter it will record actually. Top cell course actually.
That 16 meter also. This is not API tank actually. This is about D103 bolted tank.
Okay. Water.
Yeah.
Water tank. Water storage.
So normally the highest diameter is 72, or it will go more than that also.
More than also 80. More than 80 also there.
90 are this.
100.
100, whatever.
Reliance is done is 90, 92 meter diameter. Reliance crude storage, whatever Reliance is doing, it's 92 meter diameter. And one tank.
Vijay tanks also done, 110 meter actually in the Cochin oil storage tank, double wall tank actually, 110 meter.
Kochi, yeah. Okay. So I seen 100 meter in water storage in Abu Dhabi. That's
okay.
Storage, but not oil storage. So 110 also is available. So maybe we can bet maybe more than this. So we can go as required, as per client requirement.
They have not. There is no set of like that diameter. I mean to say as per API.
No, set means they given that what are the things to be considered. Accordingly, we have to do the calculation and that one. If it passes, then we can go the size. They're not restricted to the size and that one. Like pressure vessel, they're not restricted.
Pressure only. Something is there. Pressure. If more than pressure, then we will go with 620.
Yeah, API 620 we have to go if pressure is increasing. Method, variable foot method we have to go when the tank sizes are increases.
More than 50 18 kPa, in that case, generally floating roof will be there or no?
Floating roof because
No.
there is no pressure. No, your tank, your float means your roof is directly floating on the liquid, so there is no pressure or no gap in that to provide any pressure.
Okay. So means floating roof tanks will never fall under APA 620.
620 it will fall if your size is bigger, no? Then
No.
the pressure, whatever it's increase, the liquid.
Because of pressure, no?
Yeah, liquid head also it's increases, no?
No, not because of head. Only pressure.
Only pressure may not it's come. Okay, Kaushik, you got your answer.
Yeah. Thank you.
Okay, any more?
Actually, this tank is like it's a big chapter.
Yeah, big
I'm
chapter,
sure-
big learning it is.
Yeah.
When you enter, you will find the big things in that one. Everything is like that only. Atul, when he enters in heat exchanger, you will find more things. And Ramakrishna, when you enter vessels, you will find more things. We entered in tanks, we find many things like that. Okay, any more? Kaushik, you want to ask?
No, thank you.
Okay, any more? Anybody? Okay, Neeraj Pandey, do you want?
No, it's okay.
Okay. How many means did you done any tanks related projects, Neeraj Pandey?
Yes, API 650 I done. Basically, this topic what we are discussing right now about the floating roof. Floating roof we use wherever the hydrocarbon, which is vapor pressure is important, and wherever the vapor pressure is more than 0.5 psi, we generally recommend this floating roof tank. And either it is falling in 650 or 620, doesn't matter. But the main thing is the vapor pressure, and because of that vapor pressure, what will happen? Evaporation losses will be more. So where at that point of time, this floating roof tank will come into the picture. Otherwise, fixed roof tank will do.
So
That is what I know.
Yeah, this actually recommended means the whatever the vapors coming and that one the pressure it comes from process, no, it's not from mechanical.
No. See, some hydrocarbon fluid does have their own vapor pressure. When you are storing it, like petrol, petrol is evaporating fast.
Yeah.
Okay.
Yeah.
So that if you close it from top, the vapor pressure will produce inside the tank if there is a gap between top cone and cell.
Yeah.
And that will increase the pressure. So what happens that you should not allow them to, either you have to purge nitrogen on the top of it, otherwise you have to go for the floating roof tank where there is a no space between liquid and top part. So that way you are avoiding the evaporation losses. Yes.
Yeah, but the pressure and that one, the calculation of pressure and that one, it comes from you or it's mechanical?
No, actually, basically that has been given in the chemical handbook, chemical engineering handbook, that petrol has got vapor pressure more than 0.8 psi. So there you have to go for, it is recommended that, or everywhere it is going for this kind of floating roof is recommended. Otherwise, you have to provide breather valve on the top of it. So whenever the pressure will increase, the breather valve will remove that pressure and the back pressure will not be created.
Yeah.
So it depends basically what is the economic things and how much longer time you want to store it.
Okay.
So that's where the floating roof tank will come into the picture.
Okay.
Yes.
Okay, Anish, did you come across any of tank which is underground tank, Mr. Anish?
No, underground UL 140, like that you are saying, underground tanks?
UL 140, no, this API 650 only, but it's placed in underground.
So underground tank is you are talking about bullets or
No, bullets,
or
no,
not?
tanks,
Bullet
tanks only.
Okay,
No, tanks actually what happened, APA 650 is recommended for the fully bottom supported actually, this one.
Yeah.
APA 650 not recommended for underground tanks actually. Normally underground tanks means we are going with the UL 140, 142.
UL 140, 142, these are the
pump,
hazardous
normally
tanks. Yeah, and
normally in petrol pumps there are some tanks. What do you call those tanks?
It is pit
Those
tank.
tank, right? Yeah, that like pressure vessel shape, right? Shell and head or something, yeah.
Okay, so those are
Actually,
also
this is not covered for APA 650. Yeah, it is not covered about APA 650 actually.
It's a pressure vessel basically.
Yeah, pressure, like a pressure vessel. Yeah,
Correct,
it will come on
correct.
the atmospheric. Yeah, yeah.
Correct.
Because somebody, some inquiry we received saying that there are some API 650 which are placed underground. Do you want to? Do you
Yeah,
done
they
any
know,
research?
don't know actually. They don't know actually what is going on. API 650 is what referred actually. API 650 is fully saying whatever the tank in bottom fully support on the ground.
Uh-huh. Okay. So that is, means
Others
whatever they are
are-
asking, it's a wrong.
Yeah.
Means they are a wrong question.
Yeah, wrong question. Actually, wrong actually. Yeah.
Okay. So we thought that we are not done. So just maybe we missed something doing like that. So we thought, means it's
Yeah,
really
we
it's
can
not there.
recommend it. We can recommend for UL 140 to 140 above ground and underground research storage tank. We can recommend that one.
UL 142, I think it's a hazardous storage tank for rectangular or double wall tank, right?
Yeah, flammable tanks.
Yeah,
We
flammable
can use
tanks.
double wall also. We can use single also. We can use actually.
Yeah, but
Both options are there. Both options are there.
yeah, but it's for underground or it's overground.
Yeah, I remember actually UL 140 and 142. Both one thing is underground.
Uh-huh.
Other one is above ground actually. I don't know actually which one.
Okay.
Actually, UL 140 or 142.
Okay, maybe UL 140. Maybe 142 we are done many times. There's all are we done above ground.
Above ground, right? Above ground. And then, 140. Mm-hmm.
Okay. Those are with considering as a pressure vessel. It's not a. It's a.
Yeah, correct. As a pressure vessel.
Pressure vessel in a rectangular shape, right?
Yeah, there also they given some minimum thickness requirement also.
Uh-huh.
The same like API 650, they provide based on the diameter, they provide the minimum thickness we want to follow.
Mm-hmm. Okay. So like 142 also they given some thicknesses. What minimum
thickness
what?
they provided thickness. Yeah, minimum thickness also they provided. Yeah.
Okay, Ramakrishna, you want to discuss something general?
I'm giving suggestions. So I don't have any.
Okay, anybody want anything to share or anything to discuss? Whatever the weeks you faced, any issues or anything? Okay.
Yeah, okay. Fine.
Okay, so can we wind up or we want to discuss something?
Yes.
Okay then. Good night.
Okay, guys.
Guys, bye.
Thank you. Bye.
Okay, thank you. Bye.
Thank you.
Thank you.